you all for coming out. What we're going to do today is we're going to do some introductions here, and then we'll walk through our presentation, and then there will be some time towards the end for question and answer. We're also going to hang around afterwards if you have follow-up questions, so feel free to hang around afterwards and chat with us. So I'll get started here. My name is Steve Miller. I am a senior lead engineer at Booz Allen Hamilton. I've been with Booz Allen for about 5 years now. In the past 2.5 years, I've been working in the commercial automotive space. I've been working for several of the large automakers in the U.S., primarily General Motors, on their vehicle cybersecurity program. From a functional perspective, my background is sort of a combination of things, and it's one of the things that I like the most about Booz Allen is I'm able to be a management consultant, a data scientist, and a cyber strategist. So my background is kind of a combination of those things, and I'll weave some of those things into our presentation today. So I'm going to turn it over to Alexandra to kind of introduce herself here and then get the presentation started.
Hi everyone, just grab my water. All right, so hello, I'm Alexandra Heckler, also at Booz Allen on our high-tech manufacturing and retail services team. I'm a lead associate and have been focused primarily over the last couple of years on vehicle cybersecurity. Our team works with almost all of the major OEMs in the US through the Automotive ISAC, the Information Sharing and Analysis Center, where we've realized as cars become increasingly connected, they're increasingly hackable. And so the automakers have all gotten together and figured out a way to share information, because they're not just engineering away a problem, they're fighting an enemy, realistically. And so they have to team up together. They compete against one another when we're buying cars, but they've got to team up together as they're fighting that threat adversary there. Beyond the Automotive ISAC, similar to Steve, I've been working primarily with General Motors, building out their incident response plan. If your car randomly turns left on the highway, you think you've been hacked. What do? How do they fix that? How do they respond? Who across the organization needs to get involved and be aware? It's been a really fun journey joining the automotive cybersecurity space. When I first joined 2 years ago, got a call from my boss saying, hey, want to go work vehicle cybersecurity? Sure. What do you do when you don't know the answer to something? Type it into Google. So I looked up vehicle cybersecurity. 1,300 items came up. If you look today, it's 13 million after 2 years. It's been really exciting, challenging. And the whole driver behind this trend of needing vehicle cybersecurity is what we're here to talk about today. The future of the connected vehicle. So several years from now, we won't take driver's ed anymore. You might take rider's ed, because as we have increasingly connected cars, cars can drive themselves. When cars drive themselves, what do you get to do in the vehicle? Imagine if your Toyota partnered with MLB and you got to watch the Cards game tonight as you were getting driven to your grandmother's house. It'd be a pretty sweet way to ride. There's so much potential that we're seeing right now with connectivity in the vehicles, and we think that there's tremendous change in what that means for us as drivers, or now we think that we're actually going to become riders. We'll have a rider's license. You'll go through rider's ed. Recently, a British think tank actually brought this to the spotlight, saying, yep, here's exactly the test that you're going to need to take. And we've kind of talked about, as a pilot who puts on autopilot, how do you get trained? You go through a simulation training where fog hits, autopilot turns off. What do? How do you land? We might go through that kind of a training rather than the typical learn how to parallel park, which, by the way, I have done once on my driver's ed test, and that's it. So once the car can do the parallel parking for you, when it can drive on the highway for you, The testing can be different. It can be focused on the when things go wrong scenarios. Some of the other thoughts that we have around what a driver's or a rider's license might look like. Who says you have to be 16 to ride in a car? As a parent, anybody in here, I'm sure you have driven your kids back and forth to soccer practice, to first meetings, and so on. Imagine if you had a car that could just drive your kid for you. Now, granted, when you do have time to spend with your children in a car, it'll be real time together. Play a board game. Take your eyes off the road. Kind of bizarre thoughts today, but very soon. And Steve will talk about some of the technical milestones that we need to hit in order to get to that vision. So a couple of the other thoughts too around having a rider's license. Mine right now is in a card in my pocket, right? Why do I need this when I always have my phone with me? Why do I need the physical driver's license? Might be on your phone. Might be embedded in, your Apple Watch or your Fitbit. There's lots of different ways that we can prove your identity, prove that you have insurance, prove who you are and that you're the one to drive the vehicle. Who's going to be the one that gives us the rider's license, though? Is it going to be the state, the DMV, the same way that we see right now? Or will it be a U.S. issued thing? Or will it be based on the car company? There's lots of questions as to what a truly connected mobility looks like. Things even like ownership. Do you have to own the car anymore? If it can drive itself around, it doesn't need to sit idly in your garage for hours on end. Maybe we don't own our cars anymore. There are several questions that we're seeing, but we know that connectivity in vehicles is only increasing. One of the great stats that I've heard lately is a connected vehicle every year produces as much data as 6.5 times the amount of data in the Library of Congress. 6.5 times per year. What do you do with all of that? How do you get it? What do you store? What do you find in that data? It's a tremendous amount with tremendous potential. And we know that this change is coming really quickly. So what are the technical milestones? What are the things that we need to have in order to make this real? Where everybody in here doesn't drive, you ride. What does that look like? Steve.
Okay, great. So I think we're all bought in on this idea of a rider's license. I personally like to drive my car, but on the long trips to the shore or on the long trip from DC up to Connecticut, I would much rather sit in the back seat and catch up on Game of Thrones or some other TV show, and maybe play video games, catch up on work. I think this is a really exciting reality. But the question is, how do we get there? What is the pathway from, as Alexandra mentioned, that sort of that plastic driver's license to the end state flashy rider's license? So when we thought about this problem, we broke it down into kind of 4 big milestones or catalysts or enablers. And we're going to walk through each of these items in our presentation here today. What we're going to do is actually, we're going to talk about the intersection of technology and society. I think the technology is really cool and it's going to be there and it's emerging, but we can't forget the importance of adopting these technologies as a society. So let's walk through these 4 milestones here. So the first one is the Internet of Things. Internet of Things, from our perspective, is about building up trust with your connected products. We'll talk a little bit more about that in a second. So once you have this trust with your connected products, your connected vehicle, then what? Then it's about the intelligent vehicle technology. It's about your vehicle doing things that humans do. So your vehicle becomes more like artificial intelligence. So once you have the trust, once you have the technology in place, then what? Then you need to sort of unlock that technology. The intelligent vehicle technology that we'll talk through today is going to be very data hungry. It's going to be very excited to receive data, and very excited to send data back to the mothership, so to speak. So you'll need something like 5G, you'll need that connectivity to reduce the cost of that functionality and ultimately enhance the functionality. And then finally, there's the sort of the last piece here, the sort of critical piece, which is smart infrastructure. And this is going to be the hardest piece, and it's going to take the most work, and it's going to be ultimately the thing that we think will allow these connected vehicles, these intelligent vehicles, to thrive. So let's take a closer look at the Internet of Things here. So what is the Internet of Things? The Internet of Things is kind of a flashy term for things being connected. So a couple of things here that I think of when I think of the Internet of Things. So recently in my small apartment in DC, somehow like all of my light bulbs went bad at the same time. And so instead of going out and buying new cheap light bulbs, I decided that I was going to kind of go all in and get an Amazon Echo and get Philips Hue and get them connected together. And I think this is a really good example of the Internet of Things. So now I basically have totally forgotten about my light switches in my house. So when I come in the front door, instead of sort of flicking the lights on, I just say, Alexa, master on. And when I go to bed, I just sort of like lean my head out the door and I say, Alexa, master off. And so I thought about this, and what I think is really happening is I'm learning to trust technology. And I think that in order to eventually trust the intelligent vehicle, what we really need to do is trust the mundane things first, right? We need to be able to trust that, our iPhones can seamlessly connect to our thermostat. And we need to be able to trust that our iPhones, when I'm working out, are seamlessly connected to my heart rate monitor. And I think that this is an important foundation for the intelligent vehicle and ultimately the vehicle becoming part of the connected ecosystem. One other thing there that I think is interesting is that we've struggled with this problem historically. In the 1940s, there was a strike with the elevator operators, and people had to come into the elevator, and instead of being greeted by an elevator operator, they actually had to press the button to get to the floor that they wanted to go to. And at first, people were sort of crazy. They didn't really know what to do. But over time, they added the stop button, and then they had, nice music playing in the elevator. And over time, people got used to the idea of no drivers in the elevator, driverless elevators where they could just press a button, go to their floor, no big deal. And today, we don't even think twice about it. So I think the same thing is going to happen when we start trusting in our connected products. We'll eventually lay the foundation for trusting in intelligent vehicles. So once we have this trust, then what's next? So I think from my perspective, the next part of this problem is about vehicles doing things that humans do. We actually just had a chance to walk down to the floor, and honestly, I'm absolutely blown away. The stuff that you all are doing down there on the competition field is absolutely amazing, from the coding to the strategy to making those things work together, the hardware and software work together. And the same thing is happening in the automotive space. So there's this vehicle technology that's coming together. You have radars on the vehicle now, you have LiDAR on the vehicle now, you have GPS, you have sensors, you have something like 50 ECUs all connected in together to allow the vehicle to do functions, to do things. And so what we see happening, and again, this is sort of the tie into society here, is what we see happening is the vehicle starting to do things that humans do, but just do it differently. So one of the big examples here, and one of the examples that excites me as a data scientist is machine learning. So in the human world, when we're driving down the road, and this is related to the first bullet point up here, adaptation, when we're driving down the road and we see a sort of clouds forming, we start to slow down, we start to sort of prepare ourselves for the impending situation that's coming up in our vehicle. So how does a vehicle replicate that without the human? How does the vehicle do that intelligently? The vehicle does that through machine learning. It does it through extreme volumes of data, finding patterns, finding trends. It does it through understanding that all of the vehicles in front of you are now encountering this obstacle and they're slowing down. And there's data in the cloud. There's algorithms that are running in the cloud that are sensing this and sending that information back to your vehicle and allowing your vehicle to then adapt and change. And so when you start to think about things like adaptation and speech and sight and movement, and you sort of wrap them together, we can start seeing that the vehicle is starting to become really intelligent, like artificial intelligence.
And one thing to add there too, this is on. One thing to add there as well is it's not just about the vehicle driving itself, it's also about stepping into your car, and if it's 6 in the morning, you're running late to school, it already has coffee ready for you. It's preheated to the temperature that you like. The car is set up in a way that, the seats recline a little bit so you can grab a little bit extra sleep on your way to school. So it's sort of the user experience gets automated in the same way that the driving actually might happen as well.
Yeah, absolutely. So now we have, so as we're going through this path, as we're thinking about these milestones, so we have widespread trust in a connected ecosystem. We have these technologies in place. We have vehicles doing things that humans can do. What's next? So what's next, and I mentioned this earlier, what's really exciting for a data scientist and kind of a computer nerd is the idea of 5G connectivity. So I think one of the really cool facts here is that it takes something like 6 minutes today to download an HD video on your 4G LTE iPhone. With 5G, it could take 6 seconds. So you can imagine what that unlocks on the vehicle. It unlocks things like streaming HD video to your right to your car, right to the monitors that are in the back seat that your kids are watching. It allows software updates. So these connected vehicles, these intelligent vehicles are going to be a lot more software intensive. And so there's going to be a need and a demand, and I'm sure you all know this from going through your coding on your first robots. You're going to need the ability to flow down patches faster, more efficiently, and in a more cost-effective way. And then finally, what it does in terms of data coming to the vehicle is it allows that precision guidance. And we're seeing a lot of this across the industry today is if your vehicle needs to sort of be on that road and be perfectly in the center of the road, you need that precision guidance information. You need correction information coming down from the cloud to make sure that your vehicle is perfectly dead center in the road and that it's following the path that you want it to follow. But I think that's only one part of the problem. Data coming into the vehicle is only one part. The vehicle is also going to send data back to what we call the mothership, but back to the car manufacturers. So it's going to send diagnostic data back. So it's going to send information on failures that might be going on in your car. It's going to send it back up to the cloud. There'll be some engineering going on up there, and then someone could potentially call you and say, hey, look, your battery is going to fail, or hey, look, your fuel pump is going to fail. You need to make sure you take your car into the shop. Or, in a further state, all this stuff could be happening automatically. It could be telling your car to automatically go to the nearest robotic repair station. Also, it can send information back to the car manufacturer about what your behaviors are. So if you can opt into a contract with an auto manufacturer where maybe they make your car cheaper in exchange for information about where you go, what you listen to, what you're doing in the car, that can give the auto manufacturers a lot of power and a lot of information to sort of provide services to you and to other vehicles. So I think all this stuff comes together into a really powerful point, which is that 5G makes these features happen. It makes intelligent vehicle technology better and more cost effective. One other thing here too I like is the idea of the fire hose analogy. there's been some talk, and a lot of people are saying this around when you upgrade from 4G to 5G, it's kind of like upgrading your garden hose from updating your data connection from a garden hose to a fire hose. You kind of picture that, and you can see just how much more data can flow to and from the vehicle, and ultimately this will enable the intelligent vehicle features. Okay, so we have trust, we have the vehicle technology, we have the ability to get data to and from the vehicle. What's the final piece here? So the final piece from our perspective is the infrastructure piece, and this is going to be the most challenging piece from our perspective. What it's really about, when you think about the intersection of technology and society, is really kind of summoning our collective willpower to change the way our roadways work, to install the vehicle-to-infrastructure communications that are kind of going to prevent your car from going into an intersection when there's a red light. It's about stuff like allowing automated vehicles or intelligent vehicles to travel in the HOV lane and not be penalized for it, and encouraging folks to buy intelligent vehicles so that they can use that HOV lane. And then finally, it's also about the infrastructure to kind of support those vehicles. So the service stations, the automated recharging, the repair facilities, all of these things need to come together through policy and through really collective willpower to make this a reality, to sort of make the rider's license something that's real.
One of the interesting things here, just before we move on, is so when you think about infrastructure, you typically think about the government being the ones behind it. So as you look at automotive, that's mostly within the Department of Transportation. However, they are partnering with NASA, with TSA, with all sorts of other government agencies to find out what technologies are out there that we can bring from one application and plug it into another. A lot of the tech's already out there, it's just a matter of finding it. And so it's really exciting, actually. So Booz Allen does a lot of government consulting as well, which is where Steve and I both started. So it's been really fun watching some of those partnerships across these different agencies that we've worked with. They're really driving this and enabling these infrastructure pieces to all come together through that. All right, so 10, 15, 30, 100 years from now, this future can take a while to get to, but we all have a role to play here. And there's lots of different types of roles to play here. So Steve and I, we both have different types of expertise. You put us together on any project, any problem, we can solve it together. We have different strengths, and in talking to one of the student ambassadors earlier today, it sounds like your teams oftentimes are set up that way too, where you might have a coder, and then you have somebody that's actually engineering the product itself. You got to put people where they do their best work. If you've got a short amount of time to get something done, you need to bring together different types of expertise, and that's what we'll see in automotive as well. So what types of expertise do we need going forward? Are you going to play the role of the developer? Or are you going to be somebody that envisions the future, that comes up with these ideas of, let's have a baseball game in the car. You don't need to be watching the road. Watch a game. Watch Game of Thrones. And I think pairing together different types of expertise, figure out what excites you, figure out what you're good at. Ideally, they intersect with one another at some point. But there's lots of different places to get involved. So Steve's a data scientist. That's going to be absolutely key going forward. It's how you create the artificial intelligence. It's how you help vehicles communicate to one another. It's how you make sure that you've got the right information being stored, sold. And so I think these are just a couple examples here. But again, especially around the infrastructure piece, with the Politico is one of the potential roles here. Politicos aren't just liberal arts majors. A lot of the time they're actually engineers, because they've got to understand the problem. They've got to translate the problem, so then the people who deal with the dollars and cents can start to understand the zeros and ones. We've got to have a lot of different types of translators that can work across these two spaces as well.
just one thing to add there. So, so I think, I know some of you are going to be going to college very soon. And I think back to when I was in your shoes. And I actually, when I first went to college, for the first 2 years, I was a mechanical engineer. And I did a lot of sort of engineering projects, kind of like the robotics competition. But I decided that I wanted to think differently. I wanted to think about big picture stuff instead of engineering stuff. And so I changed my major to systems engineering, and I ultimately became a data scientist. But I think the important point there is that as you kind of go forth, you go out into the world, sort of keep your mind open. All of these types of people, all of these skills are necessary to solve some of these huge challenges that are in our future. And it's going to be you that are doing that. And don't necessarily box yourself in, keep your mind open, because you can contribute to this problem, whether you're a mechanical engineer, whether you're a data scientist, a programmer, or a politician, or just a manager or project manager. All of those things are part of this end state, this rider's license.
So one other thing on this too is you don't just have to be in automotive to affect automotive. We're starting to see this convergence where all of a sudden, an automotive company is actually competing with a high-tech company, where you've got Apple and Ford competing against one another around this connected autonomous vehicle. Or then you look at manufacturing. You've got all of these different suppliers across the manufacturing space that ultimately affect the ability of the automakers to deliver this for you. Telecoms are a huge provider here. Retail. There's just this convergence across all of these industries around getting you from point A to point B. Automotive isn't just automotive anymore. So you can keep that in mind as well as you're going forward. So just wanted to end on one thought here around the new horsepower, brain power. So we were walking around earlier today. We certainly saw a lot of it at work. And that's just the beginning. Imagine what you can do, not just with 6 weeks to go build a robot like you did for this. Imagine if you were given a decade. What could you build next? We're really, really excited to see where you all will take this. So we've got time for some questions. If Olga, our colleague here, will bring around the mic to you. I'll come back to you. Hello?
So what I have a question of is with the automatic cars and things like that, how would you keep people from being intoxicated or still under the influence, because they're still responsible for taking over if the car has a problem?
That's a fun one. Well, so I think one of the interesting things about autonomous vehicles is right now each country has its own way of legislating issues like this. Will we start to see different countries deal with things in the same way because automakers have to operate in multiple places? And as we get to this increasingly autonomous vehicle, those policies have to be sort of built into the car, and it's going to be more difficult, I think, potentially to create sort of multiple versions of the same thing. Go ahead.
Sorry, go ahead.
So I think the other thing with that too, right now you can have breathalyzers as you're stepping into a car. There's other technology that you can have in place. So we'll definitely see.
Yeah, I was just going to comment sort of from a technical perspective. So there's a couple of things that are happening. In the short term, there are plans to have cameras in the vehicle that watch your face as you're driving. So when you sort of flick the switch and you have autonomous driving happen, there's a camera that's watching you, and then it has facial recognition stuff. So if you
pupils as well, it watches your eyes.
Yeah, it watches your pupils, it watches your eyes, and then there's a sequence of things that happen if you sort of take your eyes off the road for too long, or if there's something wrong with your pupils. I'm sure that there are ways to, and again, this is the sort of neat part for me, is to work with the sensors, work that into the pattern recognition, kind of the data science part of the problem, and not let the driver drive, definitely not let the driver turn the autopilot on, at least in the short term, if their face is exhibiting certain functions. And that's a technology that's real and that it's here.
Here you go.
So you talked about connectivity. What do you do if you drive in a tunnel or through a desert and there's no Wi-Fi or no access to satellite?
So there's a couple of different ways to approach that. I mean, you can set up sort of vehicles create their own mesh networks, for example. And so you can kind of communicate with one another within relatively reasonable ranges.
Yeah, no, I think that's a great question, and it's a really challenging problem. Maybe a problem that you'll solve someday. But I know that in the short term, there are, and I think this is part of the reason why we have 5G up there, is there is an effort to increase precision of GPS and mapping. So GPS is only precise to a certain point, and they're making it more precise over time. But in that sort of short term, where you have semi-autonomous vehicles, there will be information that flows down to the vehicle to keep those maps super accurate, and to enable the sort of the sensor fusion that's going on the car to operate in those types of environments.
We're going to that side of the room.
So the question is that not everybody is going to be able to afford automated cars. How are you going to, because there's going to be issues with traditional cars conflicting with the automated cars. How much of the processing power is going to be stored on the automated car to deal with that?
You want to take that?
Yeah, so that's another really good question, and I think so these are really long time frame things. So we were actually talking about this question last night. It's a great question. So I think there are several scenarios to consider around how this adoption actually takes place, right? Because the semi-autonomous stuff that's out there on the road this year, so GM has Super Cruise coming out in 2017, Tesla has the autopilot out there now. These are all sort of on high-end vehicles, right? I mean, they're pretty expensive cars, upwards of $100,000. So how does that become mainstream, right? So I think that there's a couple scenarios where there's this sort of attrition scenario, where on a really long time frame, eventually more and more cars have it, and the old cars that don't have it sort of get phased out. And then there's other scenarios where maybe a car company, and this is sort of a kind of a big play, if you will, but maybe a car company wants to be the person that provides everyone in the country with automated vehicles, and then they buy back all of the old vehicles. And so there's some contract relationship that you enter into where the car company owns your car now, and you're sort of stuck with them forever, but they've bought back your car so that they can give you a fully autonomous car. So there's a couple other scenarios out there, but I think, ultimately it's going to take a while. And I think that ultimately, those things that we talked about, those big milestones are kind of the things that I would look at as sort of the tipping points of when these things, when an automotive company might actually, when 5G's out there, that might be the tipping point where an automotive company might be like, hey, we should just buy back all the cars and do a contract thing where, you get the latest and greatest.
So one other thought there too is with, how many of you have an iPhone? Okay, it's a $700, $800, $900 phone. You didn't pay that much, right? So maybe the telecoms sort of subsidize the car the same way that we see with iPhones. There's lots of different people that want your data, and so if these corporations have that access, you can negotiate your data in exchange for a cheaper product. So lots of options.
Yeah, that's the Google car. example. Google just wants your data.
Yeah, they'll give it to you for free.
So, when autonomous transformation is implemented, do you think this will lead to faster transportation times? Like, would speed limits be able to just increase?
In theory, yes.
Yeah, no, I think you're dead on. And I think, so one of the things that's happening that's sort of the groundwork for this is it's called vehicle-to-vehicle communications and vehicle-to-infrastructure communications. So the DOT is doing a lot of studies on this. There's a big study going on in Ann Arbor, Michigan on this. But once you get the safety in place, so safety is kind of another milestone on our chart. Once you get the safety features in place where you can sort of ensure vehicle safety, right? Make sure that no one's going to get hit in a crosswalk. Make sure that cars are communicating with each other and they don't get too close, given the environmental conditions. I think that's going to be the foundation for increasing speeds. I think we can see all kinds of crazy things within reason, but I think you can absolutely see that on the horizon at some point.
So earlier one of you two mentioned that even when autonomous cars became more prevalent, they would still have the feature of being able to drive them manually. Do you think that this autonomous aspect will ever be implemented into like industrial vehicles like heavy dump trucks or Caterpillars? Because unlike sedans or other family vehicles, they have really unique routes. Like, I don't know, if you're trying to bring gravel from point A to the construction site, there's always going to be so many changing variables that it's kind of hard to predict that. Ever going to happen?
Yeah, absolutely. I mean, I think that's definitely a potential application. I mean, again, it'll be a cost thing. So if it's cheaper to have autonomy than to have the labor hours, then absolutely. I think, especially as autonomous vehicles become smarter, sort of from a consumer perspective, that will help inform a lot of the other ways that we might use autonomous vehicles. But we're already in construction in particular starting to see, and in farming as well, starting to see a lot of this in place, but it's very specific applications. So when does it go fully autonomous? I think that's where the labor hours to cost of autonomy will really come to play.
Yeah, absolutely. And then there's there's a lot of study and research now on platooning. So there's technologies out there where the trucks on the highways that you're seeing, they can actually kind of get together into platoons and save costs. Right? They can be more fuel efficient. So I actually think, and I think you're onto something there, really great. I actually think that fleet operations could be the first adopters, because I think that they have the most to gain. They have the most data that they can use to help them optimize their fleet. And I think that you kind of nailed it. That's probably one of the first areas where we'll see more of this intelligent vehicle technology.
So with all of this data that's coming in and out of the cars, especially like, as you said, if the rider allows the car companies to see where they go and what they listen to and stuff like that, how are you dealing with hackers of these cars?
I feel like we must have given you that question. That's probably my favorite one to answer.
Mine too.
Do you want to go first?
No, you go first.
Okay, so how do you deal with vehicle hacking? I mean, there's a lot of different ways to approach this. So there's the threat intel piece, there's the analytics piece, there's the response piece. You've got to prepare, you've got to protect yourself, but then you have to find and fix problems because it's inevitable ultimately. And so, we've been working in this field for a while now, and Steve's been sort of on the front end, on the detection piece, on how do you prioritize vulnerabilities to fix. And then we've got some other people that we work with that have been really focused in on the threat intel, and then I've been working a lot around sort of that response. Once something goes wrong, have a plan, have it exercised, sort of know what the steps are to respond.
Yeah, so I definitely think that's what I've spent most of my time doing over the past 2.5 years is the emerging field of vehicle cybersecurity, and it's scary. I mean, I'm sure that you all have seen the Jeep hack on TV and the stuff on 60 Minutes and the stuff in the news. It's kind of a big deal. the vehicle, I look at kind of the vehicle like the computer before it was connected to the internet. When you had a computer before it was connected to the internet, you could put whatever software you wanted on there. You didn't have to worry about how it was designed because it wasn't connected to anything. No one could hack into it. But then once you connected it, right, then that's when Symantec came out and you have antivirus software, and you see how that sort of that thing happened where you needed antivirus software in order to be able to participate in a connected community. I think the same thing sort of happens in the vehicle space. And I'll actually point out another cool example. But as cars are becoming more connected, we're finding that there are vulnerabilities on these cars that they sort of didn't know existed because we never thought that they were going to be connected, right? So the Progressive insurance dongle thing that's connected into your car right now, that can connect into any car and it's connected to the internet. It's kind of like plugging a modem into your old computer. Now it's connected. Now it's vulnerable. Sort of the attack landscape has been opened up. I think in terms of sort of protecting the vehicle, there are two things. Alexandra sort of hit on the incident response piece, which I think is the biggest and most important piece for the car manufacturers, which is your cars are probably going to be hacked at some point. So you need to be able to respond. This isn't a thing where you can perfectly engineer the problem away. You're going to need to be able to respond. You're going to need a capability to respond. If someone says that they're being hacked, if 10,000 vehicles get hacked all at once, you need the ability to cut off the communications to the car. You need the ability to very rapidly react and make decisions. And if you don't, there could be lives could actually be at stake. So I think that there's some things there. And then from a data science perspective, there's things that you can do. So I mentioned in the presentation that the vehicles are going to send a lot more information back to the cloud. And so there's two things that are sort of happening there. One is, so the information that's sent back today, you can kind of think differently about it and try to find anomalies in the data and try to find intrusions sort of from an analytical perspective. But also down the road, and this is a big thing that's happening as well, 5 years from now, your cars will be purpose-built to send specific things back to the back end to find hacking. Right, so spoofing is one. If there's something happening on your network on the car, and the network is you're sort of connecting to a network that it wasn't designed to connect to, that information would get sent back. The car would detect that. That information would get sent back to the back end. The car manufacturer would sort of raise a red flag. The car manufacturer would give you a call and immediately alert you to that.
So one last thing, because this is my
Yeah, this
favorite
is my
topic.
favorite.
So the other thing is, there's two kinds of companies in the world. There's the ones that have been hacked, and the ones that don't know it yet. The challenge in automotive is we don't know the full attack landscape yet. It starts with design, but it's also your supply chain. The manufacturing floor has the potential to inject things into the vehicle. There's the services, the telecoms, the vehicle itself, your corporate IT that everything's talking to. And so right now the automakers are really getting a handle on what that looks like, but it's changing every day as you introduce new connectivity. Next question.
So once we have all the social acceptance of autonomous vehicles, we have the... It's okay, this is actually a rhetorical question. So,
Being hacked.
so yeah, exactly. So we have all the legislation in place. We've worked out all the automation issues, the networking, the infrastructure. Then can we have flying cars?
Yeah, I think it'd be fun. The challenge will be competing with drones, with planes, with all sorts of other things for airspace. All right, we've got a question up here at the front.
We're just gonna keep going. There's nothing to worry about.
We have about 10 more minutes.
Great questions. Thank you.
So if you have a car, an automated car, and it can drive you anywhere you want it to. For example, your parents, they're like, okay, drive your kid to school, but you don't want to go to school. Or for example, like someone took over the country, you want to flee the country, but you can't because government controls cars. How would you handle that? Where?
Well, it depends on whether you're in America, I guess, in part. But I think that's a really interesting scenario to think about. And so on TVs right now, you can set up, or even on phones, you can set up sort of controls as a parent versus a kid using a phone or a TV and so on. So I'd imagine that there's probably some similar settings that would be implemented in on cars. I don't know, Steve, if you can.
No, but I think so. I'm an engineer. I do like data science, analytics stuff, and that's sort of what I do all day. Is what I was doing this morning. But I think this is an excellent example of the sort of the other side of this problem, which is like, what are the ethics around some of these new technologies that we're putting in place? And so I think, well, I don't have a specific answer to your question. I think what's neat is that that challenge is a challenge that we're going to have to deal with. It adds to the sort of suite of things that we need to wrap our head around and develop policies for and legislate for to really make this come to life. Because I'm sure that's a scenario that's going to come up and it's going to be important.
Hi. So since cars are already like really vulnerable to hacking and this will only make them more vulnerable, how likely is it that these will actually, like if they're made fine or whatever, how likely is it that they would actually be made like available to the public?
So right now, the vehicles that they're designing, and even for the last couple of years, they've been going through and securing them in sort of originally it was sort of a stovepipe way. If you're building software for a car, you knew that it had to be secure. They weren't necessarily looking at the whole big picture, but at this point, they're working through and filling those gaps, plugging in holes where they can. And so I think security is the foundation that you need to have to make any of this work. So that's why, the IoT piece with trust. If you don't have trust in the technology, but also if you don't have trust in the privacy of your data, the safety of you, your kids, your brothers, your sisters, your parents, whatever it is, that's going to be key to get that right. And which is why we're seeing sort of these limited instances and getting people used to this, comfortable with this, proving the technology as sort of the starting point to build from.
And just from a technical perspective there, so there's a couple of things that are happening that is really popular across the automotive industry, one of which is called defense in depth. So it's the idea that so you sort of draw concentric circles around the asset being the car, right? There's a layer of security that goes all the way around the car, and then you keep sort of getting smaller and smaller, right? So then there's a layer of security that goes around your infotainment unit and the ECUs in your car, and then you go down deeper and there's a layer of security around the operating systems that are running on the infotainment system, and then you keep going down deeper and there's a layer of security around the communications across between ECUs, and there's firewalls in the vehicle, and all this stuff is getting engineered in. So over time, that defense in depth strategy will be I think pretty widespread in the industry, and so I think at that point your cars are going to be pretty secure. But the key thing that needs to happen in parallel with that is the idea of over-the-air updates, right? So if there is a vulnerability out there on the car that you have today, the car manufacturer needs the ability to send a patch down to that car and fix that problem. And so that's one of the kind of key milestones where once all cars have that ability, then you feel more comfortable and the ability to fix problems happens more quickly and more efficiently.
So I was wondering whether what happened to the emergency vehicles. It seems almost inevitable that we're going to increase speed, as a question said earlier. But so how fast can communication happen while an emergency response vehicle is running along at maybe 250 miles per hour, and you might get hit? Or I know in the title it's saying forget flying cars, but would that be a possibility instead of an actual ground vehicle?
All right, so in terms of the flying car versus not, I mean, again, I kind of jokingly said you're going to have to compete with drones for airspace. But again, if there's, same way that the road, there's lots of different types of vehicles on it, you'll see the same thing in the air. And so it's just maybe certain types of vehicles, sure, it makes sense to have emergency vehicles in the air or something like that potentially. And then I'm blanking on what the first question
The part
was.
about emergency.
Oh, so the emergency vehicles. So one of the things that I know Ford is working on right now is sort of vehicle to pedestrian communications. So the vehicle right now, most of the ways that it communicates to the things around it is all sort of based on vision, the ability to see things. But what happens when you have a pedestrian that's around the corner, who's glued to their phone, not really paying attention, about to cross the street? What they're trying to do is set up in your terms and conditions on your phone, say, hey, you know, we're going to communicate to all the vehicles around you. And so that way, now Ford can see people, even though they can't see them physically. And so you'll start to see more and more of these technologies integrating with one another, communicating to one another to make sure that those types of things don't happen where, you know, you've got a vehicle hitting somebody at 250 miles an hour.
So before we wrap up, if anyone wants to see some of our videos on this topic, BoozeAllen.com/first. Is that correct? So, or afterwards, you're welcome to.
We have one too.
Yeah, we can play one quick video for you. And again, we're happy to stick around for a bit. If you have, I know we saw a couple more hands here. You're welcome to come up and ask us afterwards. So thank you all for your time.
Everything is connected in the evolving automotive ecosystem. With this increased connectivity comes new challenges as well as new opportunities for those who are willing to be aggressive and innovative. At Booz Allen, we see opportunity in disruption, a chance to generate new revenues and differentiate the brand. By understanding the changing automotive landscape, you can turn risk into competitive advantage. To learn more, visit BoozeAllen.com/commercial.
Thank you all again for